So just starting to record now, and we're lucky we've not got a lecture on Monday, because next Monday's bank holiday, so we'd have lost that one, wouldn't we? So we've got today to do state space, and a week today to do root loci. So I'm going to go through the main ideas behind this, and then do some, like a past paper question and maybe another example, just for you to see what's going on. And this one is always question 4. So question 4, no, it's not question 4, it's question 3. Question 3 is always state space, and it's quite a nice question, really. It has 3 sections in, and we'll go through the 3 sections. We'll just wait until it's 4 o'clock. We've got about a few more seconds to go. So the light isn't too bad in here, but it's not brilliant either. So you can see if I'm moving on it a bit, moving the camera, it's not too bad. So we've got a few people here now anyway. So anyway, even if you don't watch it now and you're watching it in the future sometime, question 3 is on state space, and the question itself is always in 3 sections. The first section, you get given a block diagram. To convert into a single transfer function. So that's a bit of block diagram reduction. Then in the second part, it's always what we call companion form state space. So that's like a state space question built around doing a companion form question. And the third part is to do with converting the block diagram to state space. So the third part is the original block diagram. You can also convert that into an alternative state space format, and they always pick up 8, 6 and 6 marks. So that's how you get like your 20 for the question. The easiest part is, that's the easiest part, companion form, and this is quite easy as well, and that's a little bit more tricky, but not that tricky. So quite a nice question to do. You've probably done right, you can do that one right. If you do this one like almost right, you can get 3 6s, 18. So minimum mark you can get this about 18. Obviously the maximum mark you can get is 20. And so that's like the overall format of the question, and we'll go through now the 3 different parts. I've just put the central heating on, so I'm getting a bit warmer now. So the first, we're not going to quite do it in the order we've got, but the first thing we can look at is this bit on companion form, because this is quite easy. It's converting a transfer function into state space equations in companion form, and I'll show you how to do that next. So we'll do 2 or 3 examples on this. Let's say we've got transfer function GS given by, say, 4s plus 1 of s squared plus 6s plus 9. So there's a little transfer function. 4s plus 1 of s squared plus 6s plus 9. I want to convert this now into a state space equation, and we're going to put it into companion form. So the first thing to do is look at that number there. That's a 2. The bottom line's an s squared. So it's a second order state space. So you're going to have x1 dot, x2 dot, and it'll be a matrix like this, times x1, x2, plus, so times u, and y equals something times x1, x2. So this is called a state space arrangement. This is called the A matrix. It's called the B, and this is called the C. And in companion form, what we do is we put a 0 there, a 1 there, a 0 there, and a 1 there. And then that number there, these numbers here go in there in reverse order with negative signs. So it becomes -9 and -6. And these numbers here go in there in reverse order. So it becomes 1, 4. And so bingo, you can go from your state space equation off from your transfer function some state space. So we'll do different ones of these now, just for you to see how it works. And this is obviously not quite as complicated as we get in the exam. I'll just do a simple example first. So we've got 6s squared plus 2s plus 3 over s cubed plus 6s squared, 12s, 18 plus 18. There we go. So here's another one now. I'm just going to swap my pen. So this one now is 6s squared, 2s plus 3 over s cubed plus 6s squared. So 6s squared, 12s plus 18. There's a line there, but it's a bit better. So it's a s cubed there now, so it's a third order. So it's going to be x1 dot, x2 dot, x3 dot. And in here then, we now have a 3 by 3. It's going to be x1, x2, and x3 plus 2 times u, and y equals x1, x2, x3. So this time it's a third order system. And again, what we do is we put in a 0, 1, 0, 0, 0, 0, 1, 0, 1. So this top part fills up completely with zeros. We put a 1. This is called the main diagonal, just one off it. So one off it, you put 1s in, and you also put a 1 down there. So that's the starting off point. Then you put these numbers here now, reverse order with negative signs along with this. So it's -18, -12, -6. And then these numbers here in reverse order there with positive signs. So it's 3, 2, and 6. So there's a third order one. In the exam, it can be a third order or a fourth one. So it just depends. And sometimes you get an s cubed, sometimes you get s to the 4. It just depends on the day. So we'll do another one. We'll do a fourth order one this time. They won't get any bigger than fourth order. So we're now going to say s cubed plus 2s plus 9 over s to the 4th, 6s cubed, 2s squared plus s plus 27. So here's another one now. And this time it's got a 4 there. So because it's 4 states. So hopefully it will fit in here. So I get x1 dot, x2 dot, x3 dot, x4 dot. And this time we'll have a 4 by 4 matrix here. y. That'll be x1, x2, x3, x4. So there we go. Can't quite see that bit down there, but it goes x1 to x4. Like that. So same sort of idea now. We fill the top in with noughts, but put 1 off the main diagonal, so it becomes 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, then stick a 1 down there. So this is always 0, 0, 1. It's got all those noughts in, but it's got 1 off. This is called the main diagonal down there. This is 1 off the main diagonal, 1's in there. And then you've got next bit ready, but these numbers here now go along there, reverse order with negative signs. Minus 27, minus 1, minus 2, minus 6. Then these numbers go along there, so it's the 9, then the 2. Now notice there's no s squareds, so it's a 0 s squareds and 1 s, because it's like s cubed, there's not s squared, and then the s, they descend in the order, so it's going to be 9, 2, 0, 1, 9, 2, 0, 1. And bingo, you've got your, these are called state space equations in companion form, and that's worth, it's not worth much, 6 marks in the exam now. So that's companion form looked at there for you. Now that was the second part of the question. I'm just going to get my board nice and clean. Hopefully we'll all be back in the Newton building next year. So the third part, we're going to do the third part first. The third part is you might be given a block diagram. Let's do a fairly simple one, shall we? You could be given now some block diagram like this and asked to convert this into state space equations. And the way we do that is we take each block with an S term, label the output as a state. So this one here we can label as, say, x1. This one here we could label as x2, and that one there we could label as x3. Now obviously you could have that as x1 and that as x2 and that as x3 or something. So the thing about state space equations is there's an infinite family of solutions. In the exam I tend to put the labels in for you to make sure everyone gets the same answer. Now what we then do is we then draw these 3 boxes out. So I'm just going to draw them over here. I'll move the camera in a second for you. So what we do now is I can just, that's lovely, isn't it? So we draw in 3 boxes, that's still 3 boxes, and then we put each of the boxes down here, so we might as well put them in the order. So there'll be 6 over s plus 4, and the output is x1. The next one is the 1 over s, and the output is x2. And the next one is 10 over s plus 11, and the output is x3. Then what you've got to do is work out what the inputs are. So we could call that signal, say, call that one V. So this signal here now is going to be V minus x3. That's going to be V minus x3. That's plus this minus that. So the input here is actually V minus x3. But if you can see that. Then the input to this box is actually x1. and the input to this box is actually x2, because that signal there is x2 and it's going into the box. So what we've done now is we've taken our block diagram and we've simplified it down now to these three separate boxes. Then what we do is we get a state space equation for each of these and collect them up. These will give us three separate equations, collect them up into a matrix format, and we'll get our state space equations. And we can do that by saying that this is this times this. So we get x1 equals 6 over s plus 4 times v minus x3. So we say this is this times this. Now remember now what s stands for. S represents d by dt. This is the Laplace variable, and it represents the d by dt function, which is you get in differential equations. So if we take this term here now and move it up here, we'll get s plus 4 times x1 is 6v minus 6x3. This is 6 times that. That comes up. Now s times x1 is in fact d by dt of x1, which is x1 dot. So we get that x1 dot is minus 4x1 minus 6x3 plus 6v. So here's our first little equation now. So we've converted now our transfer function back to a differential equation. And we have to do that for these two as well. So let's leave that one there. So that's our first equation. So you can rub this out now and get our next one, which is x2. We don't need this bit there to give you a bit of space. So we now get that x2 equals 1 over s times x1. That's going from here now. This, that should be a 2 there, wasn't it? A good 2, wasn't it? x2 is this times this, which gives that. Then move the s now up here, so get x2 dot equals x1, because s times x2 is x2 dot. So our second equation is x2 dot simply equal to x1. So that's how we've got two of them done now. And the third one is this one here. So this x3 equals 10 over s plus 11 times x2. So this is this times this. Then move the s plus 11 up here to get s plus 11 times x3 is 10x2. But s times x3 is x3 dot. So you get x3 dot. Then we'll get 10x2 minus 11x3. And so now we've got three now differential equations. And what we do now is we write these in matrix format. So we get x1 dot, x2 dot, x3 dot is equal to x1, x2, x3 times v. And now so x1 dot is minus 4x1, so it's going to be the minus 4 goes in there, because x1 dot is that times that plus that times that plus that times that plus that times that. So the first line is this equation. And there's no x2s, minus 6x3s and 6v's. So it goes in like that. Next one is x2 dot is x1, so that's quite an easy one. That's just like that. Just goes in there. And finally x3 dot is 10x2, so I get a 10 in there. There's no x1s and there's an 11x3, minus 11 in, and no v's. And so this is the first part now of our state space. We've still got to do the y equals something times x1, x2, x3. Now to get this one, we have to go back to the original block diagram, which I've rubbed out. But if you remember, at the back end of the block diagram, there was a 1 over s there, and that was the output, and it was fed back like that, and it was called x2. Now the output was actually x2. So in this particular case, this box was the output, because it was the back end of this state, but it was also the output as well. So in this case, y equals x2. That becomes 0, 1, 0. And so then this now is the state space representation of that little system. So that's the first part is a bit on block diagram simplification. Maybe you can do that as well for completeness. I need to get the board very dry, otherwise it messes my pens up. If we go back to what we had a minute ago, we had something like this. That was v. This was 6 over s plus 4. That was 1 over s. And this was 10 over s plus 11. So very often, or not very often, always, the first part of the exam question is to simplify this block to a single block, so to a single transfer function. So that's v and that is y. So we have to do like block diagram reduction on this. So if we have a look at this now, we'll start off on this side. So this signal here is 10y over s plus 11, because this is that times that. And this signal here is v minus 10y over s plus 11. And this one here will be this times this. So that one there, if you like, will be v minus 10y over s plus 11 times 6 over s plus 4. You can see that. So then we can say this is this times this. So the last box is the last, the output is the last box times the last input. And that'll give us an equation now which describes what's going on. So I'm going to have to move the camera slightly now. I don't know where to put the camera. I'm going to risk moving it this way. So I get y equals 1 over s times this thing here. So it's going to be 6 over s plus 4. And then this part here now, just look at this part. It's v minus 10y over s plus 11. Now, this part we need to sort of mess about with a little bit. That bit should go in, but I just want to mess about with it a bit. So we rewrote this as s plus 11 over s plus 11. So it's got the same common factor. Then I could rub that out and just put one long line along like that. So this is the same now as s plus 1 times v minus 10y over s plus 11. Like that. So the advantage of this is when we've done that, we can move these three terms up here, and it makes the maths a lot easier. You don't have to do it, I've been doing this for donkey's years, and it's the best way of doing it. So then we can move now these three terms up here. So get starts by usually s into s plus 4 s plus 11 times y is equal to 6 s plus 1 times v, then 6 times 10 will be minus 60y. Now I've got to multiply this bit out now, so it's a bit more tricky. It's going to come out as s cubed. Then we're going to have a 4 and 11. So 4 and 11 is 15. It's going to give me 15s squared. And then 4 11s are 44 plus 44s. That is s plus 1v there. Don't know what you're saying. S plus 11v. Yeah, it is s plus 11v, you're right. I didn't spot that. Well spotted. My eyesight's obviously failing me this afternoon as well. So that should have been 11, shouldn't it? It was 11. I just missed a 1 out as I was going along. So that then we can add in this 60y on this side comes over. So when it jumps over this side, it changes from a minus 60 to a plus 60. So it becomes plus 60 times y equals 6 into s plus 11 times v. And then last thing to do is move all this stuff here now underneath to get the answer. So I can afford to rub the top bit off now. Now that you've spotted my deliberate mistake, I can afford to rub it out. And then that'll give us that y equals 6 s plus 1v over s cubed plus 15s squared plus 44s plus 60. So this is always done as like a show question. So it's a show that block diagram would simplify to this. So that would be the first part of the exam question really. Then the second part would be to put this in companion form. So that'd be the second part. So that would be just like x1 dot, x2 dot, x3 dot. This is the third order system because it's a s is 3 there, and that'd be x1, x2, x3 plus v. And then remember the companion form, it goes 0, 1, 0, 0, 0, 0, 1, 0, 1. And these numbers here now, negative sign reverse order, so it's minus 60, minus 44, minus 15. And then the output y is be given by x1, x2, x3, and that comes from here. So if we'd write that 6x, plus, this could be rewritten as 6s plus 6, couldn't it? So we'd have rewritten that as 6s plus 6. So that'll be 6, 6, 0. So we've done the exam questions sort of almost like in reverse order. The first bit we did was we took the thing, converted into this block diagram into state space equations. That would be like the last part. We then did the block diagram reduction. I've written s plus 1 again. Yeah, that was s plus 11, wasn't it? So it's 1166. Sorry. Should have been s plus 11 times 6. Obviously I've got something wrong with my 11 today. So anyway, but what I've just done is like a typical complete exam question, but it's not in quite the right order. The first bit would be the block diagram simplification, then the companion form, and then the conversion of it into state space using the state space diagram. So they're the sort of little skills now that you need to do the state space question. And I'm just going to clean the board a bit. You can't see it, but it's quite dirty. We'll do to give you an idea now how to do these, there must be a video on this somewhere, but also I'm doing these now. So they're the key skills that you need to do this question. So here we go. This is State Space 2020. This is like last year's exam question. It's still working okay, the pen. So we'll do it in the order it comes now. So you're given now this block diagram like this. So this is what we start off with. We're given now this block diagram, and we have to first of all simplify this down to a single block. And you probably can't see it because the autofocus isn't on, but this is what it looks like. And I give you the answer here. You can't see it because the autofocus won't work, and it's too far away to see there. I can't switch the autofocus on because it'll just mess the screen up. Anyway, you get the answer, and you've got to show now this simplifies to this. Now I've got the answer and I can see it as well, so I can make sure I get it right. So we'll do that first. Then the second part is then we're given the transfer function here. We convert that into companion form, and the third part is this variable here. That's called x1. That's called x2, and that's called x3. And so using the variables x1, x2 and x3, we have to get some state space equations for it, and that's the third part of the question, and it's marked like 866. Okay, so far so good. So the first part is a little bit more it's not very tricky, but it's not easy peasy like the other two bits. So let's have a go at doing this, shall we? So the first thing I do is I'd simplify these two, because these are in parallel here. So you could it's got just a 5 in there, that's what we've got, and it's going that way, it's going around that way. It's a bit of feedback. Okay, so it's going around that way. They always go around that way, just in case you missed it. So that's where it's going. It goes in here and around that way. We've got a 5 in there, so it's just a number, just to make it a little bit more complicated. So the first thing we do is take these two blocks here and simplify those. And because they're in parallel, you like add them together. So the first thing I'm going to do is think of, so we've added them together, it's going to be 4 over s plus 4 plus 1 over s plus 2. So these two now get added together to get the answer to this one. So we can do that as, it's just like adding fractions now, so it's going to be s plus 4, s plus 2 divided by 4, s plus 2 plus s plus 4. So when we have to bring it under a common denominator of s plus 4, s plus 2, then that gains an s plus 2, and that gives an s plus 4. So that gives us 5s, that's 4s and 1 is 5, 8, 9, 10 is 12, so it's 4s plus 12 over, and then I've just left it as s plus 2, s plus 4. So that's the first little bit there. So this part here now, this part here has now been replaced with 5s plus 12 over s plus 2 s plus 4. If you got two things in parallel, you can add them together to get an answer. And we've done that, we can probably get the equation to mess about with now. So start around here. So that signal there is 5y, isn't it? Because if that's y there, y times 5 is 5y, and that signal there will be v minus 5y, and that signal there will be 4 over s plus 6 times v minus 5y. That's not, there's a 4 there, you can see that. I think it's a 4 over s plus 6. And then we can then say that this is this times this to get our little equation. I'm going to do that on the left hand side. I'll just write it down first to get y equals 5s plus 12 s plus 2 . So I'm going to get that y is this term here times that term there. So it's going to come out as this. Y, there's that term there, 4 over 6, v minus 5y. Now what I can do now is I can take these three terms here up here, because I can move them across to slide them from underneath to the top. So I'll get s plus 2 times s plus 4 times s plus 6 is equal to 5s plus 12 times 4 times v minus 5y. So I've got the 5s plus 12, the 4, and then the v minus 5y there. So next thing to do now is to, that bit's not there, is it? There we go. So next thing is multiply this bit out. So I'm going to do s plus 2 times s plus 4 first. Okay, so that's going to come out as s squared. Where should I put it? S squared. I'm going to put it somewhere. S squared plus 6s plus 8. So s plus 2 times s plus 4 is that. Now we're going to multiply that by the s plus 6. That's going to give me s cubed. And then I'm going to have 6 and 6. 6 and 6 is 12. 12s squared. And I've got 6, 6 is 36. 36 and 8 is 44s. And 6, 8 is 48. That's 48 times y. So that's all that stuff. That should have been a y there, shouldn't it? So when I multiply that by that by that, I get those terms there. And then I've got to sort these terms out now. So 4 times 5 is 20. It's going to be 20s. 4 12s are, that's a tricky one. 4 12s, 48 plus 48 times v. So I get 20s. 20s plus 48 times v. And then got 5y times 4 times this. So there's some more terms now. So 5 4s are 20. And then 5 20s are 100. So it's going to be minus 100 sy. And then I've got 4 5s are 20. 20 times 12 is 240. So So it'll be minus 240y as well. So that's that times that times that. That's 5 times 5, 25. 4 25 is 100 sy. 12 times 4, 48. 5 48 is 240, or there's 4 5s are 20. 20 times 12, 240. That's going to be a minus 240y. So then these two terms here now have to join in with these. So if I bring out the 100 on the other side, becomes plus. So the 44 will go to 144, wasn't it? Because 100 plus 44 will be, will be 144. And then 240 coming over onto this side becomes plus 240. 240 and 48 becomes 288. So that'll become plus 288. And then this bit then has disappeared. And so then we get the answer then that y is equal to 20s plus 48 times v over s cubed plus 12s squared plus 144s plus 288. And so you can't quite see that. So there we go. And believe it or not, that was the answer that you have to show. So you can't see it, but yeah, you'll have to take my word for this. You can probably just sort of make it out, can't you? I don't know if you can. How close does it have to be? You can see 20s plus 88 over s squared plus 12s plus 144s plus 288. It's not brilliant, is it? Sorry, my camera's just off, is it? If we're still online next year, I'll buy a better camera, but I'm hoping we don't have to. So anyway, that was the first part, and you get 8 marks for that. Then the next part now would be convert this now into companion form. So we're going to do that next. So that was the first part of the question now, given this block diagram, and we have to simplify it down to a single block. You can do this in MATLAB as well. Some of the exam you can check your answers in MATLAB. It depends how confident you are with this. What I'll do is I'll come back to this in a minute and we'll do this in MATLAB. The block diagram simplification, we'll do it in MATLAB as well, just to show you that you can do it both ways. So the transfer function was given by 20s plus 48 over s cubed plus 12s squared plus 144s plus 288. That's it. There we go. Just get it in. It's 20s. The 20 doesn't come out very well, does it? My pen wasn't working so well then. There you go. Big book. Just get a bit. That's an S there. It looks like 28, doesn't it? That's a little S there. So it's a cubic equation. So the second part of the question now was to convert this into companion. So cubic equation, so it's going to be x1 dot, x2 dot, x3 dot, and we'll have a 3 by 3 here, x1, x2, x3. So it's a 3 by 3, and now we just fill it up. So we put in a 0, 1, 0, 0, 0, 0, 1, 0, 1. So fill up noughts with a 1 at the bottom. This fills up with noughts but 1 off the main diagonal. And then these numbers here now go in there, reverse order with negative sign. So it's minus 288, minus 144, minus 12. And these numbers here, those numbers there in reverse order. So it becomes 48, 20, 0. And so that would be the second part of the question. Good for another 6 marks. And the third part now, we'll have to go back to draw the block diagram again. We'll start by here, shall we? I'm just going to move the camera a touch back. Makes the board a bit bigger. So you've got a 4 over s plus 6. I've got the board didn't dry properly. If you don't dry it properly, then it doesn't work. Right, I'm just going to swap my pen because I think it's right. So here we go. So you've got a 4. This is the same block diagram now. Then here we had a 4 over s plus 4. Here we had a 1 over s plus 2. Those are added together. And that's the output y. And then here we add the 5. And we add this. V. So there's the block diagram. And on the labels now, that was x1, that was x2, and that was x3. I've drawn this thing out now. We'll just take a few seconds out on this. I'll show you how to do this in MATLAB because it's very simple. So you could block diagram simplify this in MATLAB. Obviously, you can't put this as your answer in the exam, but you could use MATLAB to check your answers, couldn't you? Just to make sure you're getting it absolutely perfectly right. So if we call that one, say, sys1, and this one sys2, say, and that one sys3, like each of those boxes we could call sys1, sys2, and sys3, we could then quite quickly use MATLAB to get the same answer for us. And we'd get the answers at different stages as well. So it'd be quite handy, wouldn't it? Let me show you how to do that. I'm just going to move this to about there. So the first thing we do is enter sys1, sys2, and sys3. So I'll put, say, so I can start about there, say, n1 is 4 and d1 is 1, 6. So I put the 4 in and then the 1, 6 in square brackets. And sys1 equals tf, round brackets, n1 comma d1. So what that, through those 3 lines, it's put that transfer function in for us. Then we can put n2 equals 4 and d2 equals 1, 4, and sys2 is tf n2 d2. Normally you'd never be allowed to do this because you'd be in the exam hall doing it and you couldn't do it, but this year you can. Last one is this one here. So you put n equals 1, d3 equals 1, 2, sys3 equals tf n3 d3. So I've just entered now the 3 transfer functions in with this bit of code here. Now I've got that much space, so I'm going to have to fit the code in here somewhere. Now next one is, remember we had to convert these, didn't we, into one block. Because they're in parallel, you can use the plus. So you can say now sys4 equals, now the ones you want to add up are sys3 and sys2. We have to add these together, so sys2 and 3 get added up, so it's equal to sys2 plus sys3. So what I've done now is I've simplified that part there into one block called sys4, and then I could multiply this by sys4. I'll just do it. I'll go back and do this neat in a minute. So what I've done now is I've done away with all this. I've got something new here now called sys4. No, we don't ignore the 5. We haven't got to the 5 yet. Give me a chance. So now, next thing we have to do is multiply this by this. So that's going to say. So we can say now. Let's say sys. I'll do it here. Sys 5 equals sys 1 times sys 4. So now got rid now of sys 1 and sys 4 and replaced it with sys 5. So this has gone now, and that's been replaced with sys 5 like that. Now this is where the 5 comes in. There's a command now called feedback, which gives us the final answer, sys 6. Sys 6 is feedback, and then in the feedback path you put the forward loop 1/3. This is called the forward loop. This is called the feedback loop. So you put sys 5 in there, comma, and then whatever thing you've got in here goes in there. So because it's a 5, that 5 goes in there. So that 5's popped into there. And then sys 6 is the answer. That would have been that funny answer we had a minute ago. So that's how you could have got your answer using MATLAB. And the plus is for it in and if they're in series, use the times. And so you need to know 3 commands: plus, times, and feedback. Plus how to put a transfer function in. So you don't need to know much, but with that trick, you could work as you got different answers out along it. You'd know what sys 5 was, for instance. So you'd have to do that yourself, and then you'd have to have done this bit, so you could check if it was correct. It's always easier, isn't it, if you've got the right answers you've got the answers in front of you, like I have here. It's easy to do them, isn't it? So that's how we could have done it, that particular problem in MATLAB. You don't have to, there'd be no MATLAB in the exam, but if you got bored of doing Dr. Ulan's questions, you could always check your other ones were correct. If I was doing it, I would do it in MATLAB first, because then you've got the answers, and then if you have a go at doing it then, and you get the same answers, you know you've done right. Certainly for next week on the root loci, the MATLAB is very good for doing it. Anyway, that was a sort of sideline that really, so I have to redraw the block diagram yet again now for the 3rd time today. It was for RS plus 6. My pen, my board dusters have got a bit damp now as well. Sorry about that. Right, here we go. I'm just going to swap my pen. You don't believe this, but behind me, my son has got his Warhammer out. But you're probably not interested in that. He's got a board with Warhammer on. So that's what I'm using to keep my pens on and my notes. That's quite handy. Let's see. Let's do it, shall we? 4. He's got, if you like Warhammer, he's got Tyranids on the Warhammer. Probably don't like Warhammer. I don't really. Right, so this is the block diagram. And that was labelled x1, that was labelled x2, and that was labelled x3, and that was labelled y, that was labelled v. So around a 10th time today I've drawn this block diagram. So the first thing to do is you recognise you've got 3 blocks. So I'm just going to move the camera up there. So put 3 blocks down. 1, 2, 3. And then the outputs from the blocks, we're going to label this and say x1, that one x2, and that one x3. I'm not sure what the inputs are yet. This first one's going to be 4 over s plus 6, 4 over s plus 4, and 1 over s plus 2. Because this hasn't got an s in, we don't bother with it. It's got to have an s term in to allocate it to a box. So what we've got to do now is work out what's going into each of these. So to work out what's going in, you've got to look at your block diagram. So that signal there is actually 5y, isn't it? Because the 5 there. So that signal there is v minus 5y. So this one here is going to be v minus 5y. Then into both these boxes, by chance, you've got x1 going into both. So that's x1, and that's x1 as well. So here's our, now we can also be whilst we're here, send me right in the block diagram again. If we look at what the output is, y is actually equal to x2 plus x3. So we could get a little equation from y from looking at the back end here, which is that y equals x2 plus x3. That would be handy for when we come to do that's y equals x2 plus x3, and that's coming from here. We've got y is plus x2 and plus x3. So y is x2 plus x3. That's a little equation. That's going to give us our C matrix at the end. So I can now wrote some of this out. Right, so now what we do is we say x1 is this times this. So I get the x1 equals 4 over s plus 6 into v minus 5y. So that's going to be this is that times that. Then move now the s plus 6 up here. So s plus 6 times x1 is 4v minus 20y. Now y, I've made a mistake already. It's not y. You can't have y here. Y was actually, well, y is given by x2 plus x3, isn't it? So 5y will be, so in these equations you can't have y's, you've got to only have x's. So this y now is no good. So y though is equal to x2 plus x3. So we can change the y to x2 plus x3. You can only have states here, not, but we had the y equation, so it was straightforward. So that's going to give s times x1 is x1 dot, and that's going to equal to this 6x1 will become minus 6x1. Then you've got minus 20x2 minus 20x3 plus 4v. So there's the first equation now, which has come from here, but we had to put the y as x2 plus x3 from there. So that was lucky that one. There's our first equation. The second one now, we get from basically simple now. x2 equals 4 over s plus 4 multiplied by x1. So we can move this at there, so we get s plus 4 times x2 is 4x1. But s times x2 is x2 dot, and that will equal to 4x1 minus 4x2, because the plus sign here, when it goes over onto that side, becomes minus. Okay, so that's the second one done. And then the third one is we've got x3 equals 1 over s plus 2 again times x1. That's this is this times this. Again, move the s up, so you get s plus 2 times x3 equals x1. Then s times x3 is x3 dot. That's going to equal to x1. Got a 2x3 in this, that becomes minus 2x3, so minus 2x3. So I've now got myself three little differential equations here. I also know that y is equal to x2 plus x3. Y is equal to x2 plus x3. So there's my equations now. I can use those equations now to get my state space equations. So three equations. So it's going to be x1 dot, x2 dot, x3 dot. So there's my, come back in focus on it. Oh, it's not very good this. I've not chosen a very good part of the board because the light is streaming on it. Well, I can fix it in a minute. So anyways, minus 6x1, so this is the first line now along here, is this one here, so it's going to be minus 6, minus 20, and minus 20, and a 4. I can show you what you call it. So it's minus 6, minus 20, minus 20, and a 4. So minus 6 x1, minus 20 x2, minus 20 x3, plus 4v. So that's a bit. Then is x2, which is 4x1, so it's 4x1 minus 4x2, and nothing else. So that's got in there as minus 4 times x1, minus 4 times, so plus 4, 4 times x1, minus 4 times x2, and 0 times v. I'm not sure now. What, you reckon the 20s are wrong? No, I don't think that's wrong. Then last one is x3 dot is x1, so x1 minus 2x3 minus 2, 0, 0. So that's gone in there. That's this x3 dot is x1 minus 2x3, so that's 1 x1 minus 2 x3. Got it wrong, haven't I? Trouble is the board's playing it now, isn't it? I'll concentrate on that. 0 minus 2. So it's 1 0 minus 2 0. And then we also need the C matrix, which you get from y. Y is equal to x2 plus x3. So it's going to be 0, 1, 1. This is like saying y is no x1, 1 x2 plus x3. So y is x2 plus x3. And there then are the state space equations for that system. So it's not, yeah, that's not too bad, is it? There's the state space equations for the system, and that would get you last 6 marks. You can't do this bit. You can't do this in MATLAB, it won't do it. But you can do the first bit. So that's let's just have a recap, shall we? So obviously every year I can just make different block diagrams up. So what we get in this, always question 3, get a block diagram. It's not coming out at all, is it? I'll do it lower down and it'll come out. This part of the board here is a bit dodgy with it's my light above upsets it. So let's move it that way. So in this question you start off with a block diagram. And you convert this into a GS. And that's a show question. That's part A. Then part B, you convert GS into companion form. State space. That's part B. So this is part A. This is part B. And then part C, the block diagram has got some states on it, like say X1, X2, X3. Using the states on the block diagram, this is using the states on block diagram, get some state space equations. So it's 3 things. This is 8, 6, and 6. So these 2 very easy to do, and this bit fairly easy. Make a couple of mistakes, you can only lose 2 marks. So you should have got 18 on this on a bad day and 20 on a good day. So I've gone over the question 2020. There's 2019 and 2018 in the past papers. You can have a go at those, and that's all we need to know about state space. That's our state space revision, really. Using states on block diagram. Sorry, my writing one's a bit funny there. Using the states on the block diagram, convert that into what we've done today, really. Okay, so that's the revision. There's probably a video on this as well. There's a video. You don't need to read your notes. Just watch the Netflix videos I've made. There's a video on Blackboard explaining all this, and with some examples in that as well. And you've got this video to watch as well, and have a practice at the past papers. And you should be able to master this one without any difficulty at all. So that's our revision on state space done. What we'll do next week is the revision on root loci. So that's the last question, question 4, which is root loci. And it's again straightforward, but with the root loci one, you can actually check your answers in MATLAB as well quite nicely. So it's worth popping into next week to have a look at how we can do that. But we've already done it in the class anyway, but just in case you've forgotten, and we'll go through. So next week is going to be next week. This is after Monday's bank holiday, so there'll be no revision lectures on Monday because it's a bank holiday. So if you've got something on Monday, you'll have to try and get the lecturer to rearrange it. But no, next week for us it is root loci, and there's part A is plotting, and part B is the angle and magnitude criteria. Using those. So the question on root loci is split into two parts: plotting root loci and then using the angle and magnitude criteria to get some more accurate things off the plot. And we'll do that this time next week. Okay, so thank you for listening. There was all 15 of us online, which isn't about a quarter of the class, isn't it? But anyway, at least this is available to video, isn't it? Okay, any questions? Any questions on that? It's very, most people get the state space question right, really, and the root loci, they get the all questions right, really. Okay, so thank you for listening today, and there's no point in overkilling this. I gave you all the stuff you need to know, and you just need to practice these yourselves now. You can watch the video again and make sure you can do all those things. If you do that, you've got another 20 marks in the bag, which is what we want, isn't it? Okay, so thank you very much for listening, and I should now stop recording.